Thank you for tuning in again. In this video, we're going to consider the laws of logarithms. The laws of logarithms is what we're going to be considering in this video. And we're going to be relating the laws of indices to the laws of logarithms, and we'll start seeing the connections that are there. Now, don't forget that when we learned indices, the first major formulae we talk about was this. So let's do it in a tabular form so that, okay, not really. Law 1. Now, let's not forget that when we learned indices, recall that we said a to the power of x times a to the power of y equals a to the power of x plus y. Now, in logarithms, what you do is to say log xy, that's the product to the base of a, equals log x base a plus log y base a. Now, look at it critically. This is in products. When you split, it becomes addition. That's the key thing I want you to consider there. Now, let's look at a very typical example. If you have log 6, obviously this is log 6 base 10. It is the same thing as log 2 times 3, which gives you log 2 plus log 3. Please note, log 2 plus log 3 is not log 5. Please take notes. Log 2 plus log 3 is not log 5. Please, that is really very important that you take note of that. Now let's look at another law. Law 2. Let's also recall again that there's the division law in indices that says that a raised to the power x divided by a to the power of y equals a to the power of x minus y. So could you just pause this video and tell us what you think the law of the logarithm will look like? To me, it's going to be like log x over y, let's say base a, equals log x base a minus log y base a. So for example, if somebody tells me that log 14 over 2 base 2, that gives me log 14 base 2 minus log, okay, let's make this 3, log 3 base 2. So these are the first two major laws of logarithm that you are advised to know. Sorry, just trying to remove all these excesses. Good. So let's put them here. The first one and the second one. So this is called the division law. This is called the multiplication law. Good. Can we also look at another fantastic theorem? Okay. Call this law 3. Can we as well recall that a raised to power 0 is 1. Therefore, in logarithm, it's log 1 base a equals to 0. So the remark here is this: the logarithm of 1 to any base equals 0. I'd like you to pause the video so that you can digest this law properly. That the logarithm of 1 to any base whatsoever will give you 0. So let's also highlight that. Then let's take the one or two more laws for this video. And that law says that when you have the logarithm to a power, the power becomes a multiplier. So power becomes multiplier, multiplier becomes power. So if I write log 2 raised to power 3, it is the same thing as saying 3 log 2. This is also very, 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 very important that you note this as well. And also, if I write something like 5 log 7 base 4, it is the same thing as saying log 7 raised to power 5 base 4. So we usually call this the power law. Good. So this is as well important. Can we look at one more law before we take a few examples? Now, we can recall that a raised to power 1 is a. So what that rule tells us is that the logarithm of a number to the same base is always 1. The logarithm of a number to the same base is always 1. So for example, if I say log 7 base 7, it will give me 1. So these are the first 5 major laws you need to know. And as a further math student or as hard math student, it is good as well that you learn the proof. Yeah, just having an understanding of what the proof is all about. Now we're going to take a few questions and we'll see how to go about solving questions of this form.